Hello my dear students. In this session we will speak with each other about the physical and chemical properties of iron. So first, the physical property of iron. Physical property, it means relatively malleable, ductile. Malleable and ductile means we can shape iron in different shapes. So it accepts to be put in molds. And molds mean take a lot of shapes by its property as a relative, malleable and ductile. Also, it has a magnetic property, and if you remember that the two main transition elements in the first transition series which have the magnetic properties are iron and cobalt, and this is a very important thing. It has a high melting point. It equals 1538. Please memorize this value. Its melting point, the melting point of iron equals 1538. It is 1538 degrees Celsius, the melting point of iron. Here it has a density of 7.87 gram per cubic centimeter. The density in the main transition elements ranges from 3.1 in scandium to approximately 9 in copper. So here all of them has more than the density of water. So the density of iron equals 7.87 gram per cubic centimeter. So what is the chemical properties of iron? The chemical properties of iron, that iron contains or exists in two oxidation states. In two oxidation states, positive 2, 3d6, positive 2, 4s2 and 3d6. Okay, the iron atom loses 2 electrons from the 4s and forms the 3d6. The more stable oxidation state is positive 3, where the 3d sublevel is half completely or half filled with electrons. So the iron can be oxidized easily from positive 2 to positive 3. As positive 3, the 3d sublevel in this case is half filled, means have 5 electrons. Okay, iron does not exist in positive 8. If we remember that manganese, which precedes iron in the same period, it is 25 4s2 electronic configuration, 4s2 and 3d5. So it can lose all the electrons and have the oxidation state of positive 7. Here iron, the first element in this series which cannot obtain the maximum oxidation state of the group. Okay, iron from group 8, iron, cobalt, nickel from group 8, but iron cannot lose the 4s2 electrons or the 3d6 electrons completely. So it forms only positive 2 and positive 3 as an oxidation state. So what is the kinds of reactions of iron which we will speak about in this session? The reaction of iron with air, the reaction of iron with water vapor, the reaction of iron with nonmetals, and the reaction of iron with acids. The reaction of iron with water and with air, these are reactions happen in the very high temperature. When the iron heated to until redness, means 500 degrees Celsius, the reaction happen. If it is a cold water, there is no reaction happen. Okay, the reaction does not occur. So iron in air, there is no reaction. Iron in water, normal condition, and water vapor in normal condition, no reaction will happen. But if we heat iron to 500 degrees Celsius, so in both cases it forms magnetic iron oxide. Let's see. Okay, the effect of air or oxygen on iron. If iron is red hot iron heated to 500 degrees Celsius, then 3 atoms of iron oxidized into magnetic iron oxide or mixed iron oxide. So 3 iron solid, 2 molecules of oxygen, 500 degrees Celsius as a condition of the reaction, forms Fe3O4, which is the magnetic iron oxide. Okay, it is a mixed oxide. It is formed from ferrous oxide and ferric oxide, the summation of both of them. So when the iron heated to 500 degrees Celsius or heated till red and reacts with oxygen, it forms magnetic iron oxide, and this reaction requires heat, strong heating. Okay, let's see here the effect of water. The same. See, 3 iron atoms with 4 molecules of water vapor because it is 500 degrees Celsius. So red hot iron heated to 500 degrees Celsius reacts with water to form the same magnetic iron oxide, the mixed oxide, and hydrogen gas evolves. So the effect of water or oxygen in the iron, in the red hot iron, making the same compound, which is magnetic iron oxide, which is Fe3O4 in both cases. So the reaction of iron, the third kind of reaction, the reaction of iron with nonmetals. Here are two cases. If this nonmetal is a strong oxidizing agent like halogens, chlorine, bromine, bromine, and iodine, these halogens with very high electronegativity, especially chlorine here, its electronegativity is 3, so it can easily take one. It takes one of the electrons, etc. electrons, so it is an oxidizing agent and makes iron 3 chloride, not iron 2. As chlorine gas is a strong oxidizing agent, so it oxidizes all ferrous or all iron 2 chloride into iron 3 chloride. So when we react iron with chlorine, we obtain only iron 3 chloride or ferric chloride. Okay, this reaction needs heat. The reaction between iron and chlorine need heat. It is not at room temperature. The other kind of reaction is the reaction of iron with normal nonmetal, but it is not from the halogens, and its electronegativity is high but not higher than the very strong nonmetals. So in this case, iron reacts with sulfur by heat also and forms iron 2 sulfide or ferrous sulfide. Okay, then the effect of acids on iron. What is the effect of acids on iron? There are two cases of the acids, of the reaction of acids with iron, whether they are dilute or concentrated. If they are diluted acids, there in this case the concentrations of the oxidizing agent, which is the negative part of the acid, we know that hydrogen here has a partial positive charge, and chlorine here has a partial negative charge. The chloride ion negative 3 electronegativity, and hydrogen ion 2.1. The difference between them 0.9. It is a polar molecule. Partial positive charge located on hydrogen, and partial negative charge located on chlorine or chloride ion. So in this case, and it is dilute, so the effect of oxidizing, the oxidizing effect of chlorine or chloride is not noticed here. So the effect here is of hydrogen, which has a reducing effect. So here we form, or the reaction form, only iron 2 chloride. Iron 2 chloride, not iron 3, because the reducing effect of hydrogen makes the iron 2 not iron 3. So it forms with the dilute acids iron 2 chloride. It is not iron 3 chloride as chlorine. As chlorine only is an oxidizing agent, make iron 3 chloride, not iron 2. Here the effect of hydrogen is very clear as a reducing agent, so makes ferrous chloride or iron 2 chloride. In case of sulfuric acid dilute, the same. Sulfate has an oxidizing agent, hydrogen has a reducing effect, so it is dilute, so the effect of hydrogen here will be clear, so it makes ferrous sulfate, not ferric sulfate. Dilute acids here, no heat. The reaction between iron and dilute acids forms iron 2 salts and needing no heat. Okay, and this is an important note. The reaction of iron with concentrated acids means like sulfuric acid, hydrochloric acid. In this case, if it is concentrated, memorize this word. Concentrated with iron means heat. So here we need heat when we react iron with conc sulfuric or conc hydrochloric. Okay, so in this case iron reacts with sulfuric acid concentrated. Its physical state should be liquid here because it is concentrated, need heat. Okay, and there are two factors here, the oxidizing effect of sulfate and the reducing effect of hydrogen. So the oxidizing effect of sulfate makes ferric sulfate or iron 3 sulfate. Okay, and the reducing effect of hydrogen makes ferrous sulfate or iron 2 sulfate. So when it is concentrated, the effect of hydrogen as a reducing agent and the effect of sulfate as an oxidizing agent appear clearly, both of them. So it forms two kinds of salts, the ferrous salt and the ferric salt, iron 2 sulfate and iron 3 sulfate. Okay, and remember that when we make a reaction of iron with conc acid, we need heat. With dilute acids, there is no heating. With dilute acids, iron 2 salts. With conc acids, the oxidizing effect of the negative part of the acid and the reducing part and positive part, which has a reducing effect, appear both of them. Because of this, it forms by this reaction ferrous or iron 2 sulfate and iron 3 sulfate. Okay, so there is a very special case here. It is the reaction of iron with conc nitric acid. It makes what is known passivity. Passivity of iron means the nitric acid has a strong oxidizing agent, a strong oxidizing effect. So it makes an oxidation to the iron atoms on the surface of the iron. So these iron atoms which is oxidized makes iron oxide. These iron oxides make a layer over the surface of the iron and prevent further interaction between the iron and the environment. So this layer make a barrier or protects the iron from further reaction with the environment, and in this case we can remove this layer, which is iron oxide, by abrasion, okay, or by dissolving it, or by using dilute hydrochloric acid to dissolve it. So there are some important notes we have explained before, but here we have to say this. Okay, we will repeat it because of its importance. Here, when chlorine reacts with iron, it forms iron 3 chloride, as chlorine is an oxidizing agent, so it makes all the iron salt iron 3 chloride, not iron 2. But here, when the iron reacts with dilute hydrochloric acid, iron 2 chloride is formed as it is dilute. Then the reducing effect of hydrogen in the hydrochloric acid appear, so it forms iron 2 chloride, as we have explained. So let's have some examples. Iron reacts with sulfur and compound X in normal conditions, forming compound X. In other conditions, it forms compound Y. So which of the following shows the two compounds of X and Y? Look, if there is it is a normal condition and heat, it forms ferrous sulfide. So this is wrong and this is wrong. In normal conditions, iron plus sulfur form iron 2 sulfide. Okay, so in other conditions iron can form only positive 3 iron 3 sulfide. This is iron 3 sulfide, this is iron 4 sulfide. Iron 4 sulfide is not an oxidation state of iron, so this is the correct answer. Okay, ferrous sulfide and ferric sulfide. Let's have another example here. Which of the following iron reactions occur at room temperature? At room temperature. This is a key word here. Look here. Iron with water vapor 500 degrees Celsius forming magnetic iron oxide, so it needs strong heating, so it is not correct. We ask about here at room temperature. Iron with chlorine needing heat, as we have explained, to form ferric chloride, so it is not correct. Iron with the strong acids with concentrated acids need heat, so it is not at room temperature, so it is wrong. So the correct answer is iron with water and oxygen forming ferric hydroxide or iron 3 hydroxide. It is the rusting reaction. So we'll take it in the Godwilling in the 4th unit electrochemistry. So the corrosion or rusting reaction, iron and water from a solution and oxygen from air forms ferric hydroxide. In this case, this rusting reaction is at room temperature and it is the correct answer. Here is another example. Iron reacts with either of dilute or concentrated sulfuric acid forming iron 3 sulfate. If it is dilute, it forms iron 2, not iron 3. If it is concentrated, it forms iron 2 and iron 3. So this is wrong. Iron reacts with sulfur, forms ferrous sulfide, iron 2 sulfide, or chlorine, and forms iron 3 chloride. Not in both cases iron 2. So this is not correct. It reacts with water vapor or oxygen at 500 degrees Celsius and forming magnetic iron oxide Fe3O4. Yes, it is correct. Yes. It can react with dilute or concentrated nitric acid to form iron 3 nitrate. With the conc nitric acid there is a so there is an oxide and the nitric acid oxidize iron, but this oxidation layer make a barrier between the iron surface and the environment. So actually there is no reaction when dilute or concentrated nitric acid reacts with 3. It is obvious that when water vapor or oxygen reacts with red hot iron or at a temperature of 500 degrees Celsius, in this case the magnetic iron oxide is formed. Let's have another example. A piece of iron was immersed in X acid for 2 days. Then after being washed with this distilled water, it was transferred to a beaker containing hydrochloric acid solution. It was observed that there is no instantaneous reaction. No instantaneous reaction here means there is a barrier on the surface of the iron element. Okay, barrier means passivity. Passivity is formed by nitric acid. So the question here asks about the X acid. What is it? It is conc nitric acid, which when added to iron, it make an oxide on the surface of the iron, and making passivity makes iron cannot react instantaneously with other materials. So the X here which make passivity with iron is conc nitric acid. And at this point we finish our session. Thank you.